Good morning, everyone. My name is Amber Ferger, and today I will be presenting homework assignment 1 for Group 1 in the Summer 2020 DATA620 Web Analytics course. So the instructions for this assignment were very simple. It was ultimately just to create a basic graph with nodes and edges. We chose to use the networks package to visualize our network, and we delivered the ultimate code in an IPython notebook. So I'll walk through simply what we did. In this instance, we are just importing both packages that we're using for visualization. One is networks and the other is matplotlib. In this next cell, you can see that we are instantiating a graph and naming it G. And then we're simply defining the edges of our graph. So this represents every connection between two nodes. And then finally, we are actually drawing the graph. We found that within this assignment, it was really helpful for us to consistently visualize the structure of the network so that we could more easily understand what we were dealing with. We can also see different attributes of the graph by looking at the number of edges and the number of nodes. Similarly, we can view the edges and the nodes by typing in these particular attributes. And we decided to take this a step further by playing around with some of the layout functions of the networks package. In this case, we have chosen to draw two different orientations of the graph. The first is just laying it out in a circular format, and the second is in a string format. And the basis behind the string format is it operates on the principle that there are as few edges crossing as possible and everything is in relatively equal length between all of the nodes. This just provides for a better visualization of the graph for more interpretability. We can also assign weights to all of our edges. You can see here that we've assigned a weight of 15 to H and I, the edge between H and I. And then we can also assign different attributes of the visualization of the graph, like labeling each of the nodes and then including bold fonts. And then lastly, we experimented with adding all weighted edges between each of the nodes. You can see here that we've also enabled it to be color coordinated so that the darker the color, the stronger the relationship between the two nodes. And lastly, we decided to do some simple analytics on our network just to get a feel for the underlying structure. In this case, we decided to do a depth-first traversal, and this was really helpful in identifying the path of shortest distance between one node and all of the others. So here we're just importing the traversal algorithm and then assigning it to the graph that we have built. We are listing all of the edges, and these represent the path that the traversal takes from one node to the end. And we can also visualize that traversal. You can see here that each each connection between each node is represented by a directional arrow. And it's important to note that when we get to node G, we have two options. We can either go to E or to H. And since the goal of using this sort of analysis is to identify the shortest path from A to J, we can see that our network goes from G to E and then back to G and then finally finishes up to H, I, and J. So in summary, we found that through this assignment, we got a better feel for the functionality of the networks package. We thought that visualizing the network in different ways helped us identify the underlying inherent structure of the graph, ultimately making it more interpretable. We've also found that working with the networks package is super easy. It provides for seamless integration of customized visualizations. And then finally, we've shown that even really simple analytical techniques like the depth-first traversal can really provide a wealth of information about a network in terms of identifying the path of traversal so we can see how easy and fast information can spread across a network. Thank you.